Hello, I'm Ming Gong. I'm currently an assistant professor at Department of Chemistry in Fudan University, Shanghai, China. Previously, I graduated as a PhD from Stanford University in 2016 and did my postdoc in UC Berkeley for 3 years, and then joined Fudan here from 2019. So my research focus is on renewable hydrogen technologies. Then I would like to briefly describe what we're doing and how our innovations might change the
Focusing on
field.
one of the greatest problems in the 21st century, that is the energy sustainability. We're now facing the significant problem of climate change, and the only solution is to decarbonize our society toward carbon neutrality. Our research focus is on hydrogen, the lightest element in the periodic table. Hydrogen is an important energy carrier that can form zero carbon energy cycles so that we can gradually decrease our reliance on the fossil fuel. And what's more, hydrogen can contribute in different parts of our society, such as making renewable fuels, making fertilizers, and even refining metals. We can say that hydrogen is the key to the carbon neutrality. However, currently only a small fraction of hydrogen is actually coming from the renewable energy and water, and the majority is still from the fossil fuel, just because they're cheap. So we have to renovate the hydrogen production technologies toward high efficiency and low cost to be competitive. With the technology innovation, we can see that in the future, the green hydrogen from the renewables will dominate the society. Water electrolysis is the major way of making green hydrogen, and its production cost is mainly determined by the efficiency of the electrolyzers. So better catalyst electrodes have better efficiencies. So I have been working on this problem for more than 10 years, trying to find the earth-abundant and low-cost catalyst electrodes for the optimal efficiency. So with our advanced catalyst design, we can now improve the efficiency by 15 to 20% with great durability. And currently, we're working on scaling up the electrodes toward practical use in large-scale electrolyzers. After joining Fudan University, I started thinking about how we can further innovate the hydrogen production technology to get cheaper renewable hydrogen. I actually discovered two major problems in addition to efficiency. One is the oxygen value problem. The co-produced oxygen is 100 times less value than hydrogen, and for most of the time, oxygen is directly discarded without any use. So we are actually wasting half of the water electrolysis. So the other problem is more severe. Currently, we can only produce green hydrogen from ultra-pure water resources, but the geometric distribution of renewable energy is almost overlapping with that of water stress. That is the same for China and for US. In other words, the water for hydrogen is actually competing with drinkable water, and obviously, water for living is more important. So our next step is to think about how we can make cheaper and more sustainable hydrogen. Our innovation is to develop this clear hydrogen system to decrease our reliance on water quality. We couple hydrogen production with different fields such as biomass upgrading, chemical industry, and environmental treatment, such that we can simultaneously produce hydrogen and value products, not only to increase the overall values, but also decrease the hydrogen cost by reducing the electricity consumption. So let's take some examples that we have demonstrated to be successful. The first example is waste glycerol. It is produced as a side product when making biodiesel, but it often has a huge contaminant level, so it is very difficult to valorize. So we developed this waste glycerol electroreforming technology, that is to grab the hydrogen from the waste glycerol to form the hydrogen gas, while making the rest into the bisoluble formate or oxalate solids. These are very important chemicals for the industry. This process is also 15% energy more efficient than the conventional water electrolysis, so that we can get cheaper hydrogen from the waste resources. Another example is the electrification of adipic acid production. Adipic acid is a very important monomer for the polymer industry to make nylons. The conventional production of adipic acid is a liquid phase oxidation by nitric acid, but during this process, nitrogen oxide pollutants are simultaneously produced that require huge efforts for treatment. Now we coupled the adipic acid production with hydrogen production with the same electroreforming technology, grabbing the hydrogen from the Ka oil precursors to form the hydrogen gas with the rest to produce adipic acid. This process is energy more efficient and environmental more friendly. In addition to these two examples, we have demonstrated some other possibilities, such as making polymer precursors and hydrogen from the wood, making resin precursors and hydrogen from the coal, and simultaneous hydrogen production and wastewater treatment. Our ultimate goal is to innovate the hydrogen production technology that we are no longer limited by the resource availability, especially the availability of clean water worldwide, and custom design the electrolytic systems based on the available hydrogen carriers so that we can make cheaper and more sustainable hydrogen at higher efficiencies. Or in other words, getting hydrogen at optima and at ease.
That is a description about our innovations. If you are further interested in our research, please visit the website or directly email me at gongm@fudan.edu.cn. Bye bye.